Hello, everybody. Mr. Odom here, and we are going to solve equations using multiplication or division. This is section 3.4, chapter 3. You're going to need your pencil, composition book, or notebook paper, and you might need a calculator. And the learning target for this video is I can solve equations using multiplication and division. Just like we had in section 3.3, where we had the addition and subtraction properties of equality, there are also multiplication and division properties of equality, and they work the same way. It basically says if I have an equation, if I have two things that are equivalent, like 6 equals 6, if I multiply one side of this equation, let's say by 2, and I multiply this side of the equation by 3, then these things are not equal anymore. This is 12. This is 18. They're not equal. So the multiplication property of equality says, hey, if I multiply this side of the equation by 2, then I need to multiply this side of the equation by 2 as well. Okay, so then we don't have this anymore. We just have 12 equals 12. All right, the division property of equality works the same way. If I take a number or take something that's equal, again, 6 equals 6, the division property of equality says, hey, if I divide one side of the equation by a number, I have to divide the other side of the equation by the same number. That way, things are still equal. Okay? So those are two more important properties. Also remember, multiplication and division are inverse properties. So when I'm solving equations and I see that the variable is multiplied by something, I may have to divide it by something, except for in a special case, which we will look at in some problems later. So let's get busy and start looking at some examples. So I'll look at problems 1 and 2. So problem 1 says I have x divided by 5, that equals negative 2. And I want to get x by itself. And right now, let me move this one out of the way. It'll get confusing. 1, I'll put it over here. I'm dividing x by 5. So the inverse operation for division is multiplication. So let me multiply this side by 5. And the multiplication property of equality says, look, if you multiply one side of an equation by something, you have to multiply the other side by the exact same thing, or equality goes away. And why do I have x by itself over here? It's because I have a 5 in the numerator, which cancels with the 5 in the denominator. So I have 1 times x, which is just x, in the numerator, 1 times 1 in the denominator, and then so really I have x divided by 1, and any number divided by 1 is just that number. So x divided by 1 is just x. And then on this side I have negative 2 times 5, which is negative 10. Remember, these have different signs. You get a negative answer when you multiply or divide. And you can check to make sure that you got the right answer, that this is the solution, by checking your answer. So x divided by 5 is negative 2. And I can go ahead and I can substitute negative 10 wherever I see x. So negative 10 divided by 5 is negative 2, and I end up with the both values, the same value on both sides of the equation. So that lets me know that this is the solution to the equation. Let me look at number 2. So number 2 says what? I have negative a equals negative 24. All right, so interesting problem. And I'm actually going to, let me put some room here. I'm going to put this negative sign. So when I have a variable and there's no number in front of it, I can put a 1 there. Because remember, this is multiplication. Negative 1 times a is just negative a. So I put a 1 there. And now I need to get rid of that negative 1. So what do? Well, we have to divide both sides by -1. Divide this side by -1. The -1's cancel, they go away, and I'm just left with a all by itself on this side. And -24 divided by -1 is 24. Now, some of you might have seen in this problem that, you know what, Mr. Odom, when you have, let me just do this one again. When I have -1a equals -24, I could multiply both sides by -1. And you could do that, right? -1 times -1 is just 1. And I end up with a equals 24. Okay, so you could use the multiplication or division properties of equality for this type of problem. And we need to check our answer just to make sure we got it right. So I have -a equals -24. And I substitute for a, and I put, so I have -24 equals -24, right? So that works. And so 24 is the solution to the equation. All right, so I want you to go ahead and pause your video here and work out problem 3 on your own. You can write your answers in your composition book. If you're listening to this through Edpuzzle, it will pause now. All right, we are back. And here's the answer to number 3. Okay, I had to divide both sides by -1.5. I just did this part in my calculator. I get -2. And then we come over here and we check and we see that, yep, both sides of the equation remain the same when I insert -2 in here where I see n. So this is the solution to the equation. All right, let's look at some more examples. So these are kind of special problems. If you notice the coefficient, there's a word from your past, from 6th grade. The coefficient, this number that's to the left of the variable, notice that it is a fraction. So how do we solve problems like this? I want you to remember this word, reciprocal. What does that mean? If I want to find the reciprocal of a number, reciprocal. If I want to find the reciprocal of a number like 1/2, the reciprocal of 1/2 is the number that I would put in the parentheses so that when I did the multiplication, I would get 1. So what number would I put in here? 2 over 1, or just 2. Why? Because things cancel. And I end up with 1. 1 times 1 in the numerator, 1 times 1 in the denominator, so I end up with 1. So remember reciprocal, okay? So that's how we are going to isolate x, is we are going to multiply, like in this first problem. Here I have 2/3 x, and what did I do? I multiplied by the reciprocal, which is 3/2. And if I multiply this side by 3/2, I have to multiply this side by 3/2. And you see the canceling that I did there. So I ended up with x equals -21. And what I put a circle around here was just to show you why I can multiply 2/3 times 3/2. I'm using the commutative property of multiplication to do that, which says the order doesn't matter when I'm multiplying numbers. Okay. So we can check it, and you see that I did, and we're good to go. Okay. So I want you to pause here, and I want you to work out problems 5 and 6 in your composition books. Again, if you're watching Edpuzzle, the video will pause for a moment right now, and we'll be back. Okay, so let's look at the answers to problems 5 and 6. All right, for problem 5, what did I do? I multiplied both sides of the equation by the reciprocal Here, there was no cross-canceling, so I just multiply the numerators together and the denominators, and this is a positive number multiplied by a negative number, so my answer is negative. For number 6, 3/8 times h, I multiply by the reciprocal on both sides. Here, there is some canceling. There is some canceling there, so that should be, cancel that out, -3. And I have -3 times 8, which is -24. And then I come down here and I check the answers to both of them, and you see that, yes, I did get the correct solutions or answers to these equations. Okay, so that's what I want. That's what I wanted to cover in this section, section 3.4. Hopefully that was helpful for you. Bring your questions to class if you have them. No reason to be confused about this. You're going to get a lot of practice. Okay, so hopefully you feel more comfortable in solving equations using multiplication and division. Usually students find this section to be easier to manage than section 3.3, which is fine. All right, so this is Mr. Odom. I enjoyed doing this with you guys. I hope you have a great day. Bye.